As we have seen in previous chapters, the golden ratio phi is a number that has infinite decimals. Therefore, we cannot draw it directly on a line. However, through history, different ways of representing it geometrically as a ratio of two segments have been discovered. Let's see some of these methods. We start with a circumference and divide it into three equal parts and connect the dots. We draw an equilateral triangle. The ratio of the distance between the sides' midpoints and the distance from the midpoints to the circumference is the golden ratio. This is Adam's method from the 80s of the 20th century. If we divide the circumference in four equal parts and connect the dots, we draw a square. We can then use Matila-Geeka's method of 1946. We divide the square in half and draw a hermetic right triangle. If we drop the hypotenuse to the right, the hypotenuse is divided in two parts following the golden ratio. And if we drop the hypotenuse to the left, as a triangle is hermetic, the segment that is the sum of the hypotenuse plus half the side of the square is in golden ratio with the side of the square. This is the hermetic triangles method from 2013. If we divide the circumference in five equal parts and connect the dots, we draw a pentagon. The diagonal of the pentagon and his side are in golden ratio. And that goes for all the diagonals on all sides. If we divide the circle into 10 equal parts and connect the dots, we draw a decagon. The radius of the decagon and its side are in golden ratio. And that goes for all the radius and all the sides. It is likely that the last two methods were known to the ancient Greeks. And there are more methods that we will see in the next chapters.